So today we are going to discuss NoSQL and HBase. All right. So we will discuss all the details about the NoSQLs in general, and then we will dive deep into HBase. Okay. So first, I want to differentiate. Before we dive deeper, I want to differentiate between few things. One, what does it mean by scale out and scale up? Okay, the other name for scale out is horizontal scaling, and scale up means vertical scaling. Okay, so I'll use scale out and scale up. What does it mean? Let's say you had one, let's say you had one cart with one single horse, and tomorrow you need to carry a bigger load, right? So you have two choices. One, you upgrade your cart such that you can add two horses, or you upgrade your cart such that you can put the elephant instead of the cart. Okay, so if you put an elephant instead of the horse, then we call it scale up, meaning you remove the horse, put the elephant. In case you add one more horse, that's scale out or horizontal scaling. Now, earlier days, in the similar way, if your server is suffering from resources, one quick way, if your server is slow, is not able to cater to the users, one way was upgrade the hardware, meaning upgrade the horse to an elephant. Remove the horse, add an elephant. Or remove the horse and add a very strong horse, buy the costliest horse available in the market. And honestly, that was the approach all of us followed till recently. If we had one more requirement of CPU and the resources, what would we do is we will just beef up our machine. We will add a bigger machine, but the data will remain the same. So this analogy is very important. Okay, I've seen this happening quite often, and the people who are from the server background, from the data center management background, would be able to understand this clearly. That we would we generally went for hardware upgrade. We would buy the costliest available server in the industry and would chest thump that we had the most powerful machine in our server. This is called scale up. And what changed with this new upcoming technologies that we realized that scale up did not help. Therefore, we need to scale out. Vertical scaling was not a solution. Instead, horizontal scaling was. You will see it very soon. Okay. Now, this is something which I want everyone to pay close attention to. This is something, if you have been working in industry since, say, 2002 onwards, you must have seen this happening in your organization often. Okay? Specifically, if you are into the B2C, as in business to consumer. Okay? So you have this great, so this is about a common story which happened quite often in 2000s. And the story starts with you have this brilliant idea, you built a great product, and then you did a launch. You are very happy with your initial public launch. All you did was you moved the server from local machine to a public DMZ server. DMZ as in demilitarized zone, as in a web server. Okay, and you are like, you open the bottle of champagne, and everybody is happy that you have done a public launch. Okay, so you are very happy with your MySQL instance with a perfect, well-defined schema, having perfect tables, having perfect relationships, and having perfect constraint and stored procedures and the triggers and everything the way you have been taught in your school, in your database class. So you're really happy that you did this public launch. Everybody wants to use your service now. Now, in couple of days, what happens is your service starts becoming popular, and there are suddenly, next thing you know is there are too many reads hitting the database. Not a big problem. We have seen this kind of scenarios quite often. So what we do is we put a caching server. Caching server, caching, what is a caching server? Something which records what it gave the last time, so that the next user is given the same thing instead of recomputing. So if there is something which is being recomputed again and again, what you do is you start keeping pre-prepared something upfront. Okay, a copy of it, something pre-prepared. And how do you do generally? You use a tool called memcached. Memcached is itself a data store in which the you can put key and value in a complex format. So no big deal, you added a cache server, but something you violated. And what is that you violated after adding a caching? And caching layer, surprisingly, none of us feel that it's a bad thing. We feel that this is the greatest design pattern we have. Why? Because it saves our life, but it kills the consistency. How does it kill the consistency? Let's say you updated a customer profile into a cache server, which means every time there's a request for a customer detail, you just serve it from the memcached. Okay, you don't go till the database to fetch all the detail, assemble it after querying, form the object. Instead, you just query the memcached, get the full object and give it to the user. And memcached is faster because it has got everything ready in the memory. Now, what happens when you add a caching layer? You add it inconsistency. And how does it happen? It happens because your reads are no longer strictly ACID. What is ACID? ACID are the 4 properties every database should have, every transaction should have. Okay. Now, the moment you add a caching layer, what happens is your data is at 2 places, one in the database, other in the cache. And when somebody changes this data, which is in the cache, it takes some time to update the memcache. It takes some time to update the memcache, which means by the time the database gets updated, you are serving the older data. You're serving the older data than what you have in the database. And that becomes a problem. If there is an object which is frequently updated, you will get inconsistencies. Okay, that means adding a caching layer actually hurt your consistency. Correct? Third, the service continues to grow and too many writes are hitting the database. So not a big problem. All we do is we beef up our MySQL server. We put lots of hardware in your database. You put like 16 cores and 128 GB RAM. Now there are 200 GB RAM servers as well available, and banks of 15,000 RPM hard drives, and so on. A usual hard drive is generally 5400 RPM, but on the server grade you have hard drives up to 15,000 RPM. So you put the costliest hardware in your database server because that's all you can do right now. Okay, and then again you're pretty happy. You're pretty happy that, oh, wow, you are able to scale your server and everything is just normal again for some days. And in these days what you do is you get some VC funding, and once you get the funding, what you start doing is you start adding more and more VPs of various verticals in your website. And what these VPs do is they add more and more features. Somebody wants a discount feature, somebody wants a EMI feature on your website, and so imagine that it's an e-commerce website and everybody you hire is for various kinds of verticals, and what they do is they add more and more features. Somebody comes up with the like Amazon Prime, somebody comes up with the idea of let's do book rentals, and all of these people, all of this development happening impacts your complexity. You keep on adding more and more tables and more columns into your product detail space and everything. So effectively, your new features start adding to your query complexity. Now you have too many joins to serve a product detail page. For example, when you buy something from Flipkart or Amazon, you get to this product page where you go through all the details. Now here you see there are so many functionalities. You have header, you have title, you have image, you have, so I'm telling, giving this example because I've seen this happening at many places in my own personal experience. Now, while on one hand your data is increasing, other hand your number of customers are increasing, that means more number of requests are coming in. Now the other hand, the complexity is increasing. Okay, so when you have so many joins just to serve one single page, what you start doing is you start forming a single table so that you don't have to do so many joins. You start merging multiple tables into one, and removing the table so that you don't have to do the joins. Now at this point of time, if you are a DBA, you will get kind of a heart attack seeing that this is something I was not taught at DBA school. Because first you let go of the consistency by putting a caching layer. Second, you are letting go of the joins, the normalization feature of the table, of the database. Okay, now still, while you are recovering from this kind of uncomfortable situation, still your marketing people, digital advertising people are marketing your website. There's a PR team going around and more publicity happening. Users are telling about your great website to each other. Now that is again swamping your server. And what you do in these circumstances, when your server is becoming swamped, you stop doing server side computation. You stop doing every server side computation. Okay, what is server side computation? You have stored procedures sitting in your server, as well as in your queries. You would see a lot of times somewhere you're translating date time into the local time zone of the user, and somewhere you are converting the currency into local currency in your SQL. Somewhere you are basically doing some kind of cleaning up the strings into some well formatted one. So all of these computations you start removing from your SQL. Let it be done by the client machine on the client side. Okay, similarly you start removing triggers and other things. And at this point of time, if you see, there are a lot of things which is against what we were taught. Lot of things here are something which a DBA kind of swears by, abides by, and something is really a horror for a DBA. And why is this happening? Just to handle the load. Okay, now, and I have seen it happening, and for the first time when I was at DE Shaw and we were managing the whole show of hundreds of terabytes of data just with Postgres. Okay, I'm not sure if you have heard about it, but Postgres is one database which is open source and is uh, used quite often in the open source world. So we had one of the PhDs whose masters and PhD was in databases, as well as his he was a great contributor to Postgres. So So we have gone through that cycle at that point of exactly this cycle at that point of time. So we stopped doing all kinds of server-side computation, and still there would be some queries that are still too slow. So what you start doing is you start periodically pre-materializing the most complex queries, and you try to stop joining in most cases. What does it mean by pre-materializing? Pre-materializing means we know that there is going to be traffic on this object very soon. So as soon as an object is modified, we again prepare everything quickly so that before the next query comes in, we have everything ready. Okay, now at this point of time, the reads might be okay, but while we were improving our reads, we hurt our writes. Okay, the writes as in the modification of data. The modification of data would keep on getting slower and slower. Adding a record would take some time to propagate across multiple tables. Now, what we start doing is we start dropping the secondary indexes, because what is an index? Index is exactly like what you see at the back of the book. Okay, what you call glossary. Okay, not like index in the beginning, but at the back. What is that index? You take out the most important words, or most you take out all the words from a book, then you compute their frequencies and order them alphabetically and put it on the back with the position where those words were found in that book. Now, similarly, you have the database indexes, whereby index contains the location where it was found in the book, in the table, and you can quickly jump into the database does it all for you. The moment you query a table on a table, your query is based on a column which is indexed. So instead of actually looking up sequentially in the table, the database will look up in a binary search way in that index. And what is binary search way? You quickly jump backward to the middle of the book in order to. So let's imagine that you're going through the index at the back of the book, and I ask you find mango. You will first look at the end of the index. You will find that, oh, the end of index is Z. So you jump into the middle of the index and then compare the middle one with mango. If that word is smaller than mango, that means you have to search in the second half of the index, otherwise you have to search in the first half. Okay, so that's like bisection method or binary search for most of you. So when you create an index on a table, what happens is it makes the search really fast. It makes the search in a logarithmic way fast. What is logarithmic way? Instead of search, if searching for one record was taking 1 millisecond, searching in 100 records will take 2 milliseconds. This is logarithmic way of doing things. Okay, so basically we create many indexes, sometimes on one column, sometimes on another column, sometimes you combine the two columns and create an index, so that when people are searching on two columns, you start giving them results. Now, when the writes are slow, why are the writes slow? Because when you modify a table, there are a lot of things happen in the background. The first thing that happens is you update the indexes, meaning every time you modify the book, you have to update the index that is on the back of the book, right? Because you might have added a keyword which. So similarly, when you modify a table, the column which contains indexes, the indexes have to be updated. And all of the indexes, first, second, third, fourth, all the columns indexes need to be updated. Now, this is slow. So you try to drop the secondary indexes in order to avoid these kind of problems. Similarly, there's something called triggers on the table. Triggers is a logic which get executed when something happens on a table. Something like when the table gets new row, or a row is edited or deleted, or the, the table get dropped, table get created. So all those kind of triggers cause the delay in the writes, because every time you modify a table, all of those trigger logics have to be fixed. So you start dropping secondary indexes and triggers, okay, as much as you can in order to make the writes faster. All right. So what you see right now after the step number 7, what all have we let go of? First, we don't care now about indexes, whether a database is providing us indexes or not. Secondly, we don't care about the multiple tables which is containing joins, which means we don't care about the primary foreign key anymore. We don't need it. Second, we do not provide the consistency. So what you see here is the things that defined databases are no longer material to you. The things, the features for which you bought the database do not matter to you anymore, right? Why? Because you want performance. You want the updates and the retrieval to be extremely blazingly fast to cater to your millions of users. Therefore, when at Amazon they faced the Black Friday, Black Friday is a time where there are a lot of near Christmas, where there are a lot of deals are given to the users, as well as there's a lot of traffic on Amazon because people buy a lot of gift to give to each other. So Black Friday is a test of a website, and Amazon failed at one of the Black Fridays. So at that time, one of the engineers said we would have to rethink what is the database. Why do we need database when we are not using any of these features anymore? So they came up with this simple scheme of things whereby a database was nothing but a small key value store. Database was reduced to 2 columns in a single table and made it such that the same table is sliced and put in onto multiple machines. So you can imagine a database to be just containing key and value. It's like a phone directory whereby first page of the phone directory is on one machine, second page of the phone directory is on second machine, and so on. And there is somebody in the middle who is keeping track of which pages are on which machine. Now, these kind of strategies would make the phone directory look up really fast. In the similar way, the database which Amazon came up with called Dynamo made 90% things really fast. Okay, so most of the things where there's a lot of demand of the performance moved to the NoSQL, which was Dynamo, the key value store. Okay, this is the real story, and probably everybody faced it, and that's the reason NoSQLs came into play. Now, general question is, what people when people ask you that, hey, what people did before NoSQLs? People used the existing databases by themselves in a kind of NoSQL way. Like, we will convert the table into very simple structure, and we will slice the table into multiple machines. We will have like 20 databases running on the network, have 20 sections of a table spread over these databases. Then there will be another server containing our web application where our first request would go, and that request will help us route our request to these other databases. Okay, so those kind of architectures had to be done by ourselves, and that's where most of our time was going at the companies like D Shaw, because we had to handle that humongous database, humongous data as humongous number of requests per second. Okay, all right. Now, question is, Again, let me recap by the way of this slide. Why do we need NoSQL? First, for big data. Second, for high availability. Third, for scale out architecture. All right. So first, for the big data. So these new genre of NoSQL databases provide you a way to store humongous data the way HDFS was providing you. Second, high availability, meaning in case there are many requests coming in, still you would be able to cater to them. Third, and as well, sorry, for high availability, when I mean is what I mean is in case some of the machine goes down, still you would be able to cater to the request. Third is scale out architecture. What does it mean by scale out architecture? In case today you wanted to store 1 terabyte data, tomorrow you might want to store 2 terabyte data, and day after that you might want to store 3 terabyte data. And you want to do it gradually. You don't want to do it upfront. You don't have that breather. As in when more and more drives are coming in, you want to add them gradually instead of waiting for all the hard drive to arrive and then start the server. Okay, so basically, as and when your server runs out of disk space or the machines, you buy more hardware and add to it. Just like in case your single horse could not handle the load, you add more horses. In case those horses could not handle the load, then you add more cattle to the single cart. So you can see that in this diagram, they have added all kinds of cattle into the cart. Okay, so this is scale out architecture. In commodity hardware, you did not have to add an elephant in order to pull the cart. You were able to get away with the usual commodity cattle, right? Similarly, commodity hardware means it's nothing special, but commodity hardware does not mean that it's a bad hardware. No matter what you do, is in case of your server, make sure that your fan is of high quality, the database is of high quality. Of course you will take care of the processor, ram and other things, but do not compromise on the quality of the motherboard and the other surrounding peripheral components. Okay, so it's not cheap, but it is commodity hardware. All right. Now, what is a NoSQL database? These are the few properties, and all of these properties govern from the same three ideas. These properties are the result of these three things. We want big data, as in we want to store petabytes of data. Second, we want reliability. We want reliability and availability, meaning in case there are many concurrent users or in case there is a hardware failure, your system should survive that. Third, you want scale out architecture. Okay, scale out architecture is the solution to first two problems. Okay, solution to first two problems, kind of, because you slowly keep on adding hardware whenever you require. And the general thumb rule of adding hardware, you can make a note of it, is when your hardware is 75% consumed, you double the capacity. When your hardware is 75% consumed, you double the hardware. Does it make sense to you? Let's say you had a machine which is running on whose memory is 75% consumed, or the disk is 75% consumed. You should double the hardware immediately, and that's a thumb rule. Probably everybody who is into data center management would know this. Okay, so what exactly is NoSQL database? NoSQL database provides big data, volume, velocity, and variety kind of things to the end user. Okay, now to do that, they need to go with the distributed architecture, and when they go with distributed architecture, What does it mean by distributed architecture? The database will comprise of many machines. And when you have many machines, some records go to one machine, some record go to another, some record go to the third one, and so on. And to handle such kind of complexity, where some record is here, some record are here, you have to have an identifier for each record, right? You have to have, like in battalions, you have to have an identifier for each person. Otherwise, you would not know where is which record, right? Therefore, you have to have an identifier for each record. So you can say that primary unique key for each table is mandatory in every NoSQL. All right. Now, NoSQL stands for not only SQL. It's non-relational. Non-relational because if you put all the relational constraints, it won't be able to provide that kind of performance. All of the distributedness will be hurt badly. I will come back to this point, that why does relational hurt our distributedness. All are open source because a database stores data, right? And when something stores your data, you have to have complete trust on that. In case the company who is handling this database is shut down, what happens to their data? Can they take it out? What happens in case the data is there in the database and database get corrupted? How can a company trust a new database? Specifically when they have these great solutions like Oracle and Microsoft SQL and Postgres, how can a company adopt a new database? It's a very difficult choice for a company, right? Therefore, if you want adoption, if you want your software to be adopted by many people, in case your product is capturing the information of the user, then you have to make it open source. All right. Third is horizontally scalable, of course. That is the property of NoSQL, and schema free. All right. And then easy replication, simple API, and manage huge data, commodity hardware. Okay, so generally these NoSQLs are not able to provide a SQL kind of structure. Okay, now there are different kinds of classes of NoSQLs. These are the kind of vague categorization. So be with me in this. First kind of databases are Accumulo and Cassandra kind of databases, which are very similar to tabular structure. They are called column-oriented and wide column. Second is document-oriented database, such as ClusterPoint, Couchbase, and MongoDB. What is a document-oriented database? Document-oriented database is what is a document? Let's talk about what is a document. Document is a complex object. Like, for example, you have to store TV shows. So the way you store is you create a kind of XML kind of a structure or JSON kind of a structure where you have TV shows. Then TV shows contain seasons. Seasons contain episodes, and episodes contain reviews and cast members. Okay, so this whole thing is created as a single object, objects within objects within object, and that's what makes document database complex. Okay, so the good thing about the document databases are, even though each row is basically an object, row does not have the flat structure of only columns, but row has an object which contains fields, contain another fields, and so on. The third is the key value kind of a store. Okay, key value are the most basic store, whereby you store the data in the form of two columns, key and the value. These are the most primitive one, and they have been upgraded such that value can be a complex object and in nowadays, which means in today's time key values have been replaced with document oriented database. But key values are something very, very important. This started as flat key and value, where key was a string, value was a string, and and later on key was a string and value was a binary data. Okay, but now they have been replaced with document oriented database. All right, now the fourth is a very new kind of database which help you store the complex structure. Okay, the complex structure of a graph. All right, while document stores only tree structure where one object contain another object contain and so on, and key value just contain store two data in a record, while the graph databases store the complex structure of complex relationships between various objects, specifically used in the social network. Okay, so you have Allegro, Neo4j, and ObjectDB, and so on. Specifically Giraffe. All right. Now the very important aspect, the CAP theorem. So after trying hard to provide ACID properties to distributed databases, few researchers realized that it's not possible. One of them was Eric Brewster. He said it through the CAP theorem. What he says is that these are the three properties that none of the database can provide at the same time. First is consistency, second is availability, and third is partitioning tolerance. What does it mean? Consistency means all users or all nodes see the same data at the same time. Okay, for example, somebody who has just written data and just reading after a microsecond of writing data, they should see what they have written. If somebody else has not written the data before them, right? This is consistency. Okay, it should not be that some of the people are getting some other information and some other people are getting some other uh, version of the information. Okay, this is inconsistency. All right, now second is availability. Availability means guarantee that every request receives a response about whether it was successful or failed. More now the number of requests that can be handled by a server, more is availability. Okay, so 100% availability probably none of the database can provide logically. Okay, the third is partition tolerance. What does it mean by partition tolerance? Partition tolerance means if there is a network disconnectivity, still the system should be running completely well. If there is a disconnectivity at any point, the system should keep running without giving the wrong data or without system becoming totally inconsistent. All right, now let me try to explain why this cap theorem is valid. I've thought about it again and again. I've gone through their paper multiple times to try to figure out how can I best explain cap theorem. Okay, so cap theorem, they have tried to make it too technical. I'm trying to make it really, really simple to understand. Okay, so I'm letting go of too much of accuracy, but this will be the best description you will get for cap theorem. All right, so why is it so that these three C, A, and P cannot be provided by a database simultaneously? Let's take a look at the first case scenario where you have this nice database, very robust one. All the users are writing to it, and all the users are writing from the same machine, reading from the same machine and writing to the same machine. That means our usual database. Okay, a single machine reading, all the users are reading from it and writing to it. Okay, now what happens when this machine goes down? Reads and writes both are lost. That means it's not partition tolerant. What happens when there are many requests? Reading the data is no longer available because all the requests will be waiting in the queue, and after a point of time the number of requests will expire, right? Therefore the availability is really bad because it's a single system. So now let's take a look at the another diagram. The first diagram was able to provide us consistency because there was a queue, people were waiting for one to finish for another, and so on. So our usual RDBMS is great when it comes to the consistency. It has transactions, transactions have all ACID properties, it has primary and foreign key relationships and whatnot. So it is great at providing you consistencies. And if in production you need consistency, then stick to the data RDBMS. Do not go with NoSQL. All right, now let's take a look at the second diagram. Okay, in second diagram, people are writing to A and reading from B. Although some people would be reading from A as well, therefore, people who are reading from A and people who are reading from B will see that data at different point of time. Why? Because there will be some time lag between data reaching from A to B, because users write to A, then the data goes from A to B, or if there are more servers like B, like C or D, then the data goes to B and C, and then users read from A, B and C, and so on. That means that if there's a network lag, B might see the data really old, but data will not get corrupted. Inconsistent does not mean corrupted because it is eventually consistent. Okay, it's not inconsistent, it is eventually consistent. We know that after a point of time everything is going to be okay. All right, because we have only one machine accepting writes. So this system is not consistent but eventually consistent, but it's available and partition tolerant. Why is it partition tolerant? In case the disconnectivity happens between A and B, okay, for some time A and B can cater to read requests. All right, and in this diagram, if there is a disconnectivity between A and B, A will stop receiving right sorry, B will not receive write request, but A will receive, and if the connectivity comes back again, A will transmit all the changes it has received after the disconnectivity. All right, so that means the things are eventually consistent as well as partition tolerant. Partition tolerant, if the connectivity between a writer and A goes down, then the writer may not be able to write, but reader will continue to read. So this system is great. It's consistent. It's eventually consistent, not consistent, but available and partition tolerant. Okay, in case machine A goes down, still you have some breather. B goes down, you have both reader and writer available. By the time A fails, you would be able to set up some backup. Okay, now the third diagram is interesting. There is one front which is accepting reads and writes, and there is a backup. And where did you see this kind of structure? We have seen it in high availability in HDFS, primary and the backup name node. Okay, so A was a name node and B was a backup name node. Now, so what happens in this kind of scenario is in case A goes down, you have B who can serve in place of A. And as soon as A goes down, B takes the place of A. At least you have the partition tolerance. But again, A suffers from the similar availability as as compared to this node in the first diagram. Therefore, it is consistent, it is partition tolerant, but it is not available. So here in this diagram, there are three servers which fall into. One HBase, other HDFS, and other RDBMS with a backup. Of course, the availability of HBase is far higher than any other databases. We will come back to this again. All right, here this kind of diagram is there in MongoDB and Zookeeper. We will study Zookeeper so you will understand how does the system work, and we have studied the HDFS backup system so you know what happens there, and we will also study the HBase so that you will understand the second and third diagram we are going to discuss as we proceed further. And the first diagram is basically an RDBMS kind of a system. Now let's move to the last one. All right, the one another idea that might you might find a little strange, and these ideas are something which are important to learn. The ideas beneath the skin of a database, NoSQL data store. Okay, these are those ideas. Starting with the cap theorem and starting with the horizontal scaling. Now, this is the third idea that we need to understand. The column orientedness. What does it mean by column orientedness? For the end user, it doesn't make much of a difference. But for a developer or for a product developer, it matters a lot. When you are given a CSV data, or when we are given a data which contains rows and columns, and we have to store it somewhere. There are multiple ways to store it. One, you first store each row into the file. Okay, you first store the first row, then second row, then third row. The second way could have been that physically you store first column first, second column afterwards, and third column. For example, you see that in the first approach, row oriented way, this is the traditional approach, the way we are storing in the file. This table is being converted into file, and the way we are saving it is in the first row we are storing 10 Joe, second row we are storing 12 Mary, third row we are storing 11 Kathy. This is row oriented way of storing in the file. The second way is you first store the first column. That means you store 10, 12, 11, 10, 12, 11. Then you store Joe, Mary, Kathy. Joe, Mary, Kathy in the file. Right? This could be another way of storing. While the first one is called row-oriented databases and second one is called the column-oriented databases. Why is it useful and why is it make sense to have column-oriented database? So few researchers found that if you compress the data, if you put the data together from each column and then you try to compress, each column is far more smaller as compared to the row wise. If you try to compress this data first and then this data, it will be far more smaller as compared to you try to compress the first row and second row. Why is it that if you try to compress this together and this together, it is smaller? Why is it so? First, if you have similar data, it is going to be easier to store it. It will be easier to find the similarities and replace those similar data with a smaller symbol. For example, you are storing in this column the sare gamma pa. Okay, this column contains the key notes, the musical notes of a music, right? That means the column will contain sare gamma pa or something like that. And when you take out sare gamma pa, you could generally replace sa with a symbol, re with some other symbol, and so on. And effectively, you'll be able to compress it to a very high level. All right. And in the second column, let's imagine that you have DNAs. and and when you have similarities in the data, say male female and so on, you will be easily able to eliminate the similarities with a symbol. Okay, so the compression, the compactness will be higher in case of column oriented data. All right, let's take in a case of say you have this table, right? This is a nice table. Now one the way you stored it in file, let's say this is a fresh file you are creating, and you store 10, 12 and 11. Of course there is a separator, okay, and then you store Joe, Mary, Kathy. Okay, so when you compress this data, okay, will it be smaller? And you compress this data together? Or imagine that you have a column called age, right? And age goes from 0 to 100. Okay, and while compression, these techniques figure that out, that this number is just varying from 0 to 100. So instead of, so they will give a, create a byte vector and make it really small. So in order to have a great compactness, we prefer to store the data in a column wise fashion. Now there was already this tussle going on that let's store the data in row oriented. Others said no, let's store in column oriented, because if you store something in row oriented fashion and you want the column together while retrieving, then it doesn't make sense. Sometimes you want all of the data of the row together mostly. For example, when you are retrieving customers information, you would want first name and last name always, okay, mostly, almost always, and but you may not want their personal address along with their official address. So there was always this tussle going on whether to keep the database data row oriented or column oriented. The clever trick which HBase did, okay, so what did HBase do? HBase planned for a column family oriented database. What does it mean? That columns are grouped together into column families, and data in column families are stored together. For example, employee ID and name will first get stored and then the second column. So I'll show you what exactly it means. So the data in different column families is stored together. So first it will store column family 1, then column family 2. But inside a column family, the data gets stored row wise. Okay? So data gets stored row wise. All right, I'll try to show you what do I mean. Okay, so first this, sorry, and first this, then kind of this, then kind of this, and then this. Okay, so you can see that. All right, so you can see, okay, so this is something stored first and then stored second, then stored 1.1, then basically this gets stored first, second, third and fourth. All right, so basically data in a column family is stored together, okay, and within a column family the data is stored in a row wise fashion. Now why, when I said why is this column family oriented, okay, very clever choice. You see here there are 3 column families and here there is a single column family. What do you think this is? Is it the first one is a column oriented, way, or the second one is a column oriented way. Which one is row oriented? This one is row oriented, or this one? So what you see here is something wonderful, because unless I went to this detail, I did not realize what's the benefit of this column family oriented thing. The reason was, it was politically very correct decision, or architecturally it's a correct decision. You can see that if you want explicitly that I want column oriented database, then you make one column per column family. If you want your database to be stored as row oriented, put all the columns in a single column family. Alright, so that was about the concepts behind NoSQL and HBase. Now we will move on to the next stage, understanding HBase. Alright, so what exactly is HBase? HBase is a NoSQL database which is column family oriented and provides you C and P out of CAP, meaning it is able to provide consistency and partition tolerance, but not much of an availability. Not availability as in not too much of availability. The TPS is quite high, as in the transaction per second is quite high in HBase, but again, it's not very good at availability. Okay, so C and P, again, HBase was created by by following Google's Big Table paper. So out of the three papers published by Google, the third paper about Google's Big Table was a basis for HBase creation. It's good for hundreds of millions or billions of rows. If you're not expecting millions of rows, you stick to your classic database. If you are expecting the rows more than a million, only then you use HBase. Okay? Otherwise, you may not find it too much of a use. All right. Now it's strongly consistent. It basically it's not eventually consistent. It is strongly consistent. Okay, it provides automatic sharding, as in dividing the data amongst multiple servers by the way of region servers, and it provides automatic failover in case one region server fails, other takes over. All right, and it provides a good Hadoop HDFS integration, and it is massively parallelized processing using. It provides MapReduce processing via MapReduce. Okay, it provides various kinds of APIs in Thrift and Java, and since it has Thrift, that means almost every language is supported. And the API is very basic, like get and put. Okay, it provides two more features called coprocessors and Bloom filter, which we will discuss in detail. All right. Now let's go through the basic architecture of HBase. HBase has one master and others are region servers. Just like name node and data nodes, we have master and region servers. Master contains information about what is stored in which region server, and region servers store the actual data. So imagine that there is a very huge table. It is cut into portions and put on many region servers, and then master is keeping track of from what page number to what page number, or from which word to which word is stored in which region server. If you have used Oxford dictionary, on the dictionary you have at the top of the page the range of words, right? From this word to this word is what is contained on a page. Now imagine that you basically break the dictionary into into page by page. You put one page on one machine, another page on another machine, and you make a central record of the top of the page saying from this range to this range was on this page, and so on. And then you can quickly, whenever people are asking for a particular word, you can quickly talk to that particular region server containing those pages. Okay, and the region server, how do they store the data? They store the data on HDFS. Okay, region servers store the data into HDFS. They don't store the data into the physical file system. Instead they store, because each region server is supposed to store a portion of a big table. Okay, and region servers store the data in HDFS, which means that every portion has got 3 copies. In case one region server is down, then you have another region server which would be having the access to the same data. All right, so also the coordination between master and region server is done through zookeeper. Okay, so instead of master keep taking the attendance all the time from region servers that hey, who all is up, like the way I'm doing continuously, that hey, are you there, are you there, can I start now? So similar to that, instead of doing that, there is another guy called zookeeper who is keeping track of which region server is up. That makes master free from the taking attendance from all right, so this way, while master is redirecting the users to store the data in region servers converting the data into the actual file and putting that file into HDFS. Okay, and these region servers are coordinating amongst themselves as well as with the master using the zookeeper. So zookeeper, instead of asking every region server, where are you up or down, are you up, and give the attendance, zookeeper is taking the attendance, and master is asking the zookeeper that who all are available right now. All right, now let let's understand few of the dynamics. Okay, so let's understand what does it mean by a reason. So HBase stores data into tables are automatically partitioned into regions. Horizontally they are cut. Okay, they are horizontally cut into regions. Initially, when you store data, the data is going to be stored in the region. Master is just keeping the record of from which row range to which row range has gone to which region server. Okay, so a table is divided into regions. Initially, when you start creating a table, it contains only one region. And then as you keep adding more and more rows to this region, the region will the table will keep on increasing, and when it reaches certain threshold, it will be cut into exactly two half, and moved to different region servers. Okay, so after a point of time, when and then you then these reasons, these two reasons which have been created out of a single table will keep on expanding independently and then keep on dividing again and again by itself. Okay, so the architecture of reason splitting is just like B tree. Okay, don't mind if you don't have read B trees. So the idea is that you have a big table, and then it is cut into two halves, then each of them keep on increasing, the reasons independently keep on increasing. As soon as these reasons will further split into sub reasons and so on. Okay, it's like a small tree. As they become bigger, they become two branch, and each branch, when they become bigger individually, they keep on splitting up further and further. So as and when the data is growing, more regions are being created, and the they are moved to different region servers. Okay, so each region comprises of a subset of table rows. And a reason, basically what would define a reason in HBase? Okay, an important thing to understand in case of HBase table, this table contains one row, as we told you earlier, that every NoSQL has one column which has the ID. Similarly, HBase contains one column which is row ID, and this row ID is mandatory in the HBase table. The columns or other values in this table are optional, but every row must have an ID. And the way HBase stores the data, it is ordered by the row ID. It is ordered by the row ID. So each region will also contains the row ID, okay, or row key in the ordered fashion. Okay, when you have something ordered in ordered fashion, you can always say that from this node to this node, from this word to this word has gone into first region, from this word to this word has gone into second region, and so on. And this is possible only because the the data in a table is ordered by row key. Okay, the row key. So exactly the way each page in Oxford Dictionary contains the range, as in from this word to this word, that denote that okay, this page is from this word to this word. Similarly, a region is denoted by the table it belongs to, and first row key inclusive and last row key exclusive, meaning if it says 1 to 10, that means on the reason it will contain only up to 9, not 10. Okay, now if this is the table that contains all the row keys, some of the row keys would be in one region, some of the row keys will be on another region, some of the row keys in the second region, and two regions could be on one region servers. For example, this region and this region are on the same server, these two are on same server, these two are on same server. Okay, so this is kind of a layout of region servers. Now, the most important part to learn about HBase is data model. All right, the data model is something which we need to understand clearly, okay, because that's what is going to be a problem when we understand, when we try to store data. What exactly is data model? Okay, so you have a certain data, certain expectations from a certain requirement with respect to the user, that people want to fetch this data first, then and so on. There's certain usage pattern from the user. Okay, and on one hand you have the usage requirement, on other hand you have the limitations and the features of the database. Now you as an architect or a developer or system engineer, you have to figure it out, you have to translate your requirement in order to fit to the features and in order to avoid the limitations of the database. So so it's very important to understand the of data model provided by the database so that you can fit it accordingly. Okay, so the most concise definition of data model in case of HBase is that is given by the father of the people who wrote the main paper on big table, because big table is the kind of inspiration for HBase. So the paper by Jeff Dean and Gamawat and one more person, says that the big table is sparse, distributed, persistent, multi-dimensional sorted map. This is a very, very important definition because I can't take a single word out of it. It's just crisp. Whatever word I could remove from it, I have removed that. And this definition is probably the most crisp, and not a single thing is wrong. Okay, so let's take a case of a map. So big table is a map. Map means it is a key and value, meaning it has got row key and it has got value. Multidimensional means the value contains more fields. It's not a single value, it contains more cells. Okay, sorted means the keys in this map are ordered, which means if you can reach to first key and then you try to access the second key will be bigger than the first one, and so on. Now your question would be that if the key can be a string, then how do you order it? It's very simple. The data is basically converted into binary, and binary data can be ordered based on 0 1s. Okay, now it is persistent, meaning it's not only in the memory but it is kept on the disk. Next, it is distributed. So this hash map is on not on one computer but on many computers, distributed to multiple computers. Okay, next is sparse, means the dimensions, the parts, the attributes of values can be anything. If first value contains 3 columns, second might contain some other 3 columns, or it might contain the same 3 column values as the first one, right? Meaning the column would, if you try to make it like a table, most of the values would look empty to you. Okay, that something would give uneasiness to anybody from the databases background. The whole table would be hardly 1% filled. 99% of the table would be sparse. Okay, and that's very much true for storing the semi-structured, unstructured, or any kind of data that into a table. Okay, so the table can be this sparse. You can store as many columns as you want, as many new columns as you want in each row. Each row can have different set of columns and the table will be perfectly working fine. Okay, unlike our databases. All right, so a table, HBase organizes data into table. Table names are string that are safe for file system path. These are few important things. When you're creating a table in HBase, make sure the name of the table is clean, with which a file can be created, because region server is going to create a folder. A folder is going to be created with the same table name in the HDFS. Row table contains rows, okay, and rows are identified by row key. Row key do not have to have any data type. They can be a binary data. You'll be amazed at the fact that row key can be the full movie. Okay, I've stored like 20 MB data in row key earlier at one point of time, and it is just perfectly fine to have any data in the row key. All right, so the row ID itself could be a good data storage. Next, column family. While defining a table, the only thing we have to define is what is the name of the table and what are the column families it would contain. That's it. There is no data type of the column family, only the name you have to provide, because the data is in HBase table is grouped by column families. So table have rows, rows have row keys, row keys can contain binary data, table names have to be file system safe. Similarly, column family. Okay, so table have column families that you defined up front, and inside column family you can keep on adding as many columns as you want and whenever you want. You don't need to define any columns at the time of table creation. Okay, so column family impacts the physical arrangement of the data such that data within a row is so data within a column family will get stored together. So you need to define them upfront and not easily modifiable. But luckily, Hue provides you a way to create column family at later point of time. Even programmatically, you can do that, but it's not very efficient process. Okay. Every row in a table has the same column families. Okay, but that does not mean that all the column families need to have any column. All the column families can stay empty for a basically when we are creating a row, we can just create a row with a row key and not put any data in it. A row need not to store data in all its column family. Since HBase will be asking HDFS to create folder with the name with column family under the table name, inside the region, therefore the name of the column family has to be file system safe. Column qualifier or column data within column family is addressed by column qualifier, or you can say column name. And also you don't need to define the column name upfront. Column name need not to be consistent between the rows, meaning one row can have some columns, other row can have some different columns or same columns. It doesn't matter. This is something which will take time for you to gel. And like row keys, column name itself can be a binary data. That is something very interesting which I found. Okay, so when I was designing the database, I was amazed to find that I can store a lot of data in the column name itself. And we utilized it. We utilized the name of the column as the storage of the data. So we kept on adding more and more columns, and column name itself was containing data, and our cell was containing just a very small rudimentary yes or no or one or two, while the column name was containing the whole movie. Okay, so that's a very important part. So row key can have binary data, column name can have binary data. So column name and row key behave exactly same way. Okay, so a cell is defined by table name, row key, column family, column name, and the version. Version is something you need to understand. Every cell has got a version. Okay, so you have row, you have column family, column name, and inside column for each row, for given a row and a column family, there is a cell. Okay, and cell has multiple versions. Okay, when you change the value of a cell, the older value get pushed to the older version and the newer value takes the place. By default, there are three old versions kept, two old versions and the one current version kept in HBase. You can change it at for every row. All right, so values within a cell are versioned. Version number, which is by default the timestamp, it's if it's not specified, when you don't specify a version that hey this is the version number, if you don't specify for each cell, then by default the current time is used as the version, and while retrieving the latest version based on the timestamp is taken if you don't specify the version number. Okay, the number of versions retained by HBase is configured for each column family. The number of versions retained by HBase is configured for each column family. The default number of cell version is 3. Alright, so you can see that here there is this table, nice table. It has got row key which are ordered, you can see that, and it has got two column family. One column family is called personal and other column family is called office, and inside personal column family you have name, other you have residence phone. Okay, and in office column family you have phone and address. Please keep a note that two different column family can have column qualifier as the same. It could have been phone instead of region phone. It is completely okay. All right. So each cell, you see the cell here, that's the actual value here, and this cell is basically having three different versions. All right. In other way, you have the row key. Row key has different column families, and column families have different columns, and different columns has different timestamps and their cell values. Okay, this is another way of look at the structure of HBase table. So let me explain it by using a spreadsheet. Okay, you can see that here. Okay, so let's say the first column here shows the some column names. These are in the first column, let's say name, age, and so on. Okay, and let me just put a row key here. This is row key. Okay, and let's say there is the first row key, or let me just make the row key as email ID. Okay, for this row key there will be some name and some age. For another row key, you may decide not to put anything here, but you may decide to add one more column called let's say marks. Okay, so it could have only, let's say, name, let's say Vivek, and marks. Okay, so this is kind of what do you say, empty. Okay, these are kind of empty. Similarly, there could be another ID which can say, I don't care about any of these fields, I want to create my own field called full name. Okay, and they can say Prasant. Okay, T. You can see that this one has chosen to keep not like this, like this. Okay, this one has chosen to skip all these columns. That means these are also going to be black. Now let's take a very good example. The main reason why big table at Google was invented was this. They wanted to store the the whole world's data in a structured format or semi-structured format. So instead of just dumping it into HDFS, they wanted to do a different kind of analysis over the data. Okay, and they needed it. And the way they stored was very interesting. For every new page they encounter, they create every new domain they encounter, they create one row in this table. Okay, where the row key is basically the domain name, the URL. URL goes into the row key, and there are two column families. One is called contents, other is called anchors. As and when they encounter a new URL, they create a row here, and after downloading its data from that page, from that URL, they add the data into the contents column family. Okay, as we told you, the column name could be anything, it could be even empty. So this first column is an empty column inside a column family called contents. So this table has got two column families, contents and anchor. All right, and the row key is based on the URL, and contents contain the first column, which is blank, that contains the default HTML. There could be another column called PDF. If a web page is in the form of PDF, you could have a separate column. Next is the anchors. As and when you encounter that a page is being referenced by another page, you add a column inside anchor column family. For example, www.cnn.com is referring to cnnsi.com by the name CNN. The label on the link is CNN. Similarly, this page is pointing to mylook.ca with the name cnn.com. If this page had links to 500 links, 500 URLs, there will be 500 columns under anchor column family. Okay, so you can see that the important part to understand here is you can add as many columns as you want. So effectively, this table will contain as many columns as it would contain the rows, because for every new URL there is a reference links. Okay, so horizontally we are adding more and more columns for each reference which is found. So first we download data, then we understand what is there inside the HTML. The raw data is stored under content, and after we understood the links references, we add columns into this table, saying anchor column contains these details. Okay, that means we always know who are referring to a website. Now, so you can see that. Now one more aspect is that this row key is a reverse URL. Why reverse? So that Microsoft.com or email.microsoft.com or www.microsoft.com and say msdn.microsoft.com, if you sort them just like this, what would happen is there will be other website that will come in between them, because Microsoft.com is the suffix to the rest of it. Therefore, if you sort it, the sorting will be based on the subdomain, right? That means Google.com would be somewhere in between, which means if you want to get all the data related to Microsoft.com from this table, it will be difficult. Therefore, what they did was they stored the domain name in a reverse order, saying com.microsoft.email. Okay, similarly here com.cnn.www. So if they had cnn.com, google.com and www.cnn.com, google.com could have come in the midway, because the data is ordered by row key, right? So that all the row key belonging to cnn.com come together, the row key has been inversed. Instead of saying cnn.com, they're storing it com.cnn. So all the subdomain for cnn.com would come together, so that if you get the first key, you'll be able to scroll down, you will able to go through the next rows instead of again searching. Therefore you have to use all these information about the data model in order to exploit every feature. Okay, so one-to-many relationship is created by adding more and more columns, and the data which you need to gather is either in the same column family as well as it is in the same it is basically having the row key such that the data comes together if sorted by row key. All right. So you can see all, and also the text, it contains the timestamp. All right, let's take a look at this. There's a table with the name Deepti table. Under this, you see there is a big number. That means it has got only one reason. This is a reason. Okay, this is a reason ID for this table called Deepti table. Under the reason, you have three, these two basically, finance and HR. Okay, your finance and HR, two column families. Okay, there is nothing inside HR, and there is something inside, sorry, there is nothing inside finance, but there is something inside HR. So HR is a column family, this is the reason ID, this is the table name, and this is the common folder where every table is being stored. Okay, so you can see clearly that for this table there will be a table called in this. Let me just open HBase. Okay, so inside here there is a Deepti table. It contains HR and there is a name here. You can see that. Okay, so again let me recap whatever we have understood so far. And okay, let me recap whatever we have understood so far. Indexing is based on row key. Tables are stored based on, tables are sorted based on row key. Each reason is, each reason of the table has row key and row key, I mean, each reason of the table has sorted row key. Okay, and it is basically, reason is described by starting and ending key. Everything in HBase table is stored as byte array. Atomicity is only at the row level, meaning all the changes to a row can reflect in a single shot. There is no multi-row transaction. Also, column families have to be defined upfront. Column qualifier or the column names are dynamic and can be added at the right time, and they are stored as binary data. So the table name and the column family name are something that need to be clean because there is going to be a file with that name. There has to be a folder with that name. All right. So those are the design guidelines. All right, let's try to access HBase. Although from here you can go here in HBase and edit the table the right way. You can create a table and add the data. All right, let me open the web console, copy the data, paste the data, and copy to clipboard, paste. All right, here you can say HBase shell, all in small. Okay, and basically you can execute these commands. All right, you can execute these commands. Let's just check the status first. It says 2 servers and 2 are dead. I'm not sure if it's working or not. Okay, this is something, I think it's already working. It's unnecessary, it's showing the dead. And let's try to create mycf 6 fab. Okay, so we'll say, instead of saying mycf, we'll say mycf dot 6 fab. Okay, so that we have, okay, so let's create a table called my table. It says the table already exists. Okay, so we can say delete table mycf 6 fab. You have to put it in single quote. What's happening with this? Wrong number of argument. Does it require saying table? Oh, it's my table, sorry. Okay, so yeah, that was the problem. So instead of changing the name of the column family, we were changing the name of the table, we are changing the column family. So let me try to do it. So the table has been created. Create my table 6 fab. All right, so here we go. So we have just created my table 6 fab, and we can just check if it has been created or not. You can see all the tables are listed here. You could also say things like my table dot star and put it in single quotes. You can see that my table 6 fab and all. We can say scan my table 6 fab and it is showing 0 rows. Okay, now we can add. What is important to you is that it's basically treating everything like a key value. I'm saying put into this table this particular row with this particular column and a value. Okay, so I'm adding one row 2 here and one row 1 here with different column, and you can see what does it mean. Okay, alright, you can see that the table is enabled and all of the details about the table. Now before deleting a table, you have to disable a table and then delete a table. Okay, right now I'm not going to disable it. Okay, so I'm going to enable the table again. So the way it works is you have to disable the table so that all the transactions should finish, and then you can gracefully drop the table. Alright, brilliant. Now moving on to the next point. So physical store we have discussed, locking which we have discussed. Okay, so HBase provides you the scanners. Okay, scanners are more like cursors in a traditional database. As I was explaining to you that once you get to a particular row, you can get the next row and so on. That's done via cursor scanners. So scanners returns rows in the order of row key. Users obtain scanner by saying result scanner rs equals to htable.getScanner, and then you give the reason, give an argument called scan. Scan is essentially the starting of the row, ending of the row, basically where to stop, where to start the row key scanning, and which columns to return as part of the result, and a filter to run on the server side. Sometimes you may want to run some logic on the server side itself before getting the results. Okay, so you can run that filter on the server side itself by specifying scan. All right, next is every time we say give me next rows, it is going to make a trip to the region server. All right, if you are interested in understanding how you talk to HBase through Java, you can take a look at this code. You first create the config object, then you get the admin handle on the config object, then you basically create a table description, and on top of this table description, you have column description. So column description has column family, and you are adding column family. So it's quite comprehensive. You can see that. The important part is that you can add every row is basically contains the put. Okay, so you basically put the data, get the data. So the API might look very primitive to you. Okay, so you can see that. So get and put is what it contains. All right. So all right. So HBase provides a Java API to write MapReduce, just the way we wrote MapReduce to churn the data in a usual manner. In the same way, you can run MapReduce over HBase. The only difference here is that the input data to your mapper is each row, and row contains row key and the column definition, all of them. Okay, so for each row in HBase, your logic of MapReduce mapper would run, and then whatever is the result of your mapper will be aggregated based on the key value provided by the mapper. All right, so you can see that we create the MapReduce exactly the way we created the MapReduce in our usual case of churning the file. Here we are trying to churn a table. We are saying my mapper extend a base class called table mapper, and it's going to give out this key and this value. Okay, it's going to generate key value where key is going to be text and value is going to be integer. All right, and by default you are going to get row in the method called map as the input, and the value is going to be of the data type called result. Result is nothing but the column details of each row. Okay, and in context you will write your key and the value. All right, exactly the way we did the MapReduce earlier. Then you create the reducer by extending table reducer, and your output is going to be contain the row key and the data from the data type of the columns. So you can see that here we are saying put.add. Here we are going to say the row key out of after we are producing the output. We are saying that we don't need to specify the row key. Instead, I want to give out the column family name and the count and so on. All right. So this is what a MapReduce looks like, and afterwards you stitch it together and then execute the MapReduce job over a source table for a small selection of scan, and then you provide mapper class, reducer class, and so on. All right. So that's about MapReduce over HBase. All right. So see you tomorrow. That's pretty much for today. Okay. So tomorrow we are going to discuss a little bit about Bloom filter and the normal APIs. Okay. Thank you everyone. Have a good day. Bye bye.